So we started with factor analysis, understanding what is factor analysis. So what is factor analysis? What is factor analysis?
Data summarization.
It's a data summarization technique. And is it independent, interdependence or dependence method?
Interdependence.
Interdependence.
It comes under interdependence because there is no,
Correlation between factors.
no. It's an interdependence. Correlation is the assumption. Correlation though is the main thing that has to happen. Interdependent because there is no dependent variable.
Okay, wow.
Okay, it's an interdependence technique because there is no dependent variable, unlike regression, where you have a dependent variable and an independent variable, where you are checking the causality. Okay, the cause and effect. You are checking cause and effect in regression. So the effect, you check the effect in which variable? Independent variable, right? And the cause is because of the predictors, that is independent variable. So in regression, where you have this dependent variable, and that is a dependence method. But this factor analysis, it's an interdependence method. Why it is interdependence? Because there is no dependent variable. We are not saying that there is any cause and effect. There is no dependent or independent variable. We are checking the interdependence. So it's a data reduction or data summarization technique. It's factor analysis is a general name denoting a class of procedures primarily used for data reduction and summarization. And it's an interdependence technique. So variables are not classified as either dependent or independent. Instead, the whole set of independent relationship among variables is examined in order to define a set of common dimensions called factors. So how are we doing this data reduction? Are we decreasing the data? Are we deleting the data? What we are doing? What are we doing? How are we? Okay, we are reducing data, but how are we doing this?
We are grouping dependent variables under one factor.
Exactly. We are grouping the variables. And so that these variables, through this factor, the variance of these variables can be explained. So we are grouping these variables. We are not deleting the data. Okay. We are data reduction or data summarization does not mean that we are deleting data. What we are trying to do is we are trying to find these underlying variables which can explain maximum variance of these variables. So that we don't have to use 5 variables and we can do our job by using just 2 factors. So why we are doing this? Why we are reducing the data? What help are we going to achieve by reducing the data? 5 variables से ही क्यों नहीं start किया हमने? Why we are reducing it to 2 variables, 2 factors? How this will help?
Ma'am, can you repeat?
So in our analysis, instead of using 5 variables, why we are running factor analysis? Why we are going with 2 factors? From 5 variables, we are going to 2 factors. Why we are doing that? Is there anything
Better understanding.
better understanding, or the task of researcher is like the researcher has to
So basically, like marketing, we do segmentation of
Mhm.
bringing homogeneous people together. So grouping homogeneous things together. So that is why we are doing, and we can focus basically on 2 factors according to their properties. And so yeah, that's why we are grouping them.
Yes. So basically, we are grouping homogeneous or say, correlated variables together so that the researcher is able to do the analysis more easily. So it's difficult to handle, say, 100 variables, and it's a better thing. There's this law called law of parsimony. So if you have less data, you can analyze well. So that is the reason. Okay, which one is Correlated, which one is not correlated? Is it factor which is correlated? These factors, are these correlated?
Factors are not correlated and
These are,
variables are correlated.
Yes, ma'am.
okay. And these variables are correlated, yes. So if I say that these variables, the correlation between these variables are high, what I'm implying, can you say anything about the factor? Will they end up in same factor?
Yes, ma'am. If high correlation, they will end up in the same factor.
Yeah, that are the high chances. So purpose of using factor analysis, I showed you this example, how, in banks, they can do factor analysis. So what was the purpose of running factor analysis? How many observed variables they had? Number of observed variables in this example.
15.
15.
Yeah, 15 observed variables. So this was part of our questionnaire. This was in our questionnaire. Okay. And this data is what? Metric or non-metric? This is,
Non-metric.
no, this is interval and ratio. It's metric data. Okay, so we take metric data in factor analysis. So we had this 15 attributes. What was the problem of this bank? What is it trying to do by using factor analysis? What is this bank trying to do?
Evaluating it.
How do customers evaluate banks?
How do consumers evaluate banks to basically come up with smaller dimensions, come up with smaller themes so that they can understand how customers make this evaluation? What are the things that customers look for while selecting banks? So they came up with how many factors then?
4.
4.
Four. And can you read what four?
Traditional services, convenience, visibility, and competence.
Yes. So they came up with these four factors, and it was concluded that consumers evaluated banks using these four basic factors of traditional services, convenience, visibility, and competence. Next, we discuss that what are the various circumstances where we can use factor analysis. So first was to identify latent or underlying factors. So like here, the latent one is this traditional services, convenience, visibility. All these are latent variables, say honesty, satisfaction. So to identify latent or underlying factors, you can use factor analysis. Say psychographic variables, like I showed you that example of Telecom brand. Okay, so psychographic variables, if you have to reduce 6 psychographic variables into 2, so basically based on some latent or underlying factors, these can be grouped. So first is this, to identify this latent or underlying factor. Second is to identify a new smaller set of uncorrelated factors. So I mentioned something about multicollinearity. What is multicollinearity?
It is a
What is
problem
multicollinearity?
which shows high
It's a
correlation between two independent variables.
Dependent variable.
Yes, a problem when when two independent variables show high correlation. We don't want that to happen in case of regression. So what we can do is that we can run factor analysis, we can club those variables which have high correlation, maybe get factor scores, and then we can run regression. Okay, so we can solve the problem of multicollinearity. So for subsequent multivariate analysis, be it regression, be it discriminant, be it segmentation, okay, all these things we can use factor analysis. So first step would be to do factor analysis, and then you go back to regression and do it again. Okay. And there is something called surrogate variables. I'll discuss the surrogate variables also. Basically, by running factor analysis, you check the factor loadings and certain values, and you can see that which variable is very important. So for that factor, say here, In factor 1, you check certain tables and then see the value of factor loading is very high for easy to read monthly statements, for example. And for these variables is very less. So you can take this variable as surrogate for factor 1. So you can remove all these variables and just take this variable. So that's something called surrogate variable. Okay. I'll show you this in Nike case study. Okay, so these are the three circumstances where we can use factor analysis. Next, we discussed about this study, this example, wherein this telecom brand did this segmentation study, and by factor analysis, that was the first step. That by factor analysis, we had hundred of statements because we were trying to figure out what is the psychographic profile of these respondents and how what is the attitude towards technology, attitude towards internet, and all those things to get a better understanding of these respondents. And but the problem was that we ended up with say 100 statements. So what we did is we ran factor analysis and we reduced these 100 statements to 22 factors. Okay, tech savvy, technology dependent, and all these. Okay. So there's something called a priori factor. So this was done using a priori factors, and I'll cover this also. What is a priori factors? So we came, yeah, this is demographic, this is psychographic profiling. We did profiling of these respondents after that. So yes, so this was the example of market segmentation wherein you group variables or respondents. In factor analysis, you group variable. What is the difference between factor and cluster? What is the difference between factor and cluster?
In cluster, we divide customers, and in factors, we group. In cluster, we group customers, and in factor, we group variables.
Yes. In cluster, we group customers or respondents or my sample
Cases.
or cases. Yes. Okay. Or rows. Whereas in factor, you group the variables. So factor analysis, like I showed you this example of telecom group, where we use factor analysis to group variables, which were then used through cluster analysis. We group them into customers. That was one. And then second was to identify the dimension. What consumer consider important while taking a buying decisions. So in bank example, I showed you there were four factors based on which customers decide which bank to choose. Okay, after that we discussed some business applications. Where can we use factor analysis? Like market segmentation. So economy, convenience, performance, comfort, and luxury are some factors. And based on this, we can group customers and come up with 5 segments like economy seekers, convenience seekers, all these. In product research also, say a brand is launching this product, a new toothpaste brand, and they want to know what are the various factors what are on which customers evaluate a toothpaste brand. What is it that they look for when they are buying a toothpaste brand? So it's cavities, whiteness, fresh breath, price, taste. These are very important parameters. Okay. Similarly, for advertising studies, so if I'm a brand which is into frozen food, I would like to know what is the media consumption habits of target market. So I know that, where my TG is, what is it, where can I target my TG? Okay, so they can be heavy viewers of cable TV nowadays, OTT, Netflix, is it Instagram, the media, what is their media buying habits that I can see in pricing studies. So the characteristics of price sensitive customers, whether they are economy minded, home centered, how they are, what are the characteristics. So basically you are clubbing the data, you are grouping various parameters you are using to get better understanding your customer, but then it becomes so difficult for you to analyze all these variables, and then what you do is you try to group them, and that is what factor analysis does. We talked about latent variables, say loyalty, satisfaction, honesty. All these are latent variables. These are hidden variables. Okay, so these are hidden variables, and how we do that, how we arrive at these hidden variables is that first we ask question through your questionnaire. Okay, so something called observe variables, and we see some patterns in our observe variables. Based on that covariance, based on that correlation, this factor analysis model tries to group it and comes with this underlying variables. What are these underlying variables? So I showed you this example, say depression, anxiety. All these are unobserved factors. So a person can say that, okay, I am facing insomnia. These are the symptoms. Or I am having suicidal thoughts, hyperventilation is a condition, nausea. He is experiencing all these things. But is it because, what is the underlying reason for this? Why these symptoms are coming? Is it depression? Is it anxiety? Okay. So what factor analysis can do is that it finds this covariance or variance between these observed variables and try to explain it through some underlying variables. Here, depression and anxiety. Okay. What you have to remember is that there's something called unique factor, which is unique to each variable. For example, insomnia even is unique factor, and there is something called shared factor. So depression and anxiety is shared factor or common factors. Okay. So what is, then I discussed about commonality. Commonality is basically the variance. So covariation in insomnia, in this insomnia, is because of some shared factors, that is depression and anxiety, and some unique factors. Okay, and this is called commonality. The variation that is because of shared factor is commonality. Okay, next we discuss the assumptions of factor analysis. So what are the assumptions of factor analysis?
Variables must be intercorrelated.
Yeah, variables must be interrelated, or there must be correlation between these variables.
Sample must be homogeneous.
Yeah, sample size should be more than 100 or around 100. So if you have 5 variables, okay, so it should be 5 by 5. 25 is the sample size that you should have. But we prefer something around 100, okay? We prefer higher sample size for factor analysis. So if you have 20 variables, so around 100 is something that you must have. So that is the assumption. Next, we'll discuss there are certain steps. I'll go through this one by one, and you will remember all these steps, so don't worry about it. You formulate the problem. That is the first thing. Let's do it through Nike case study. So you formulate the problem. The problem in this case is that through underlying variables, we have to group Nike users. Okay? Through underlying variables, we have to group Nike users. So we asked awareness, attitude, preference, intention, and loyalty from some 45 respondents. Okay, rank Nike on awareness, rank on attitude, preference, intention, loyalty, all these 5 variables. Now, what we want to do is that a respondent must have ranked awareness, Nike on awareness, say 5, has given 5, attitude 4, all these things. So based on this, based on these rating, whatever these respondents has given, we are trying to club these variables. Okay, remember, we are trying to club these variables. We are trying to club awareness, attitude, preference, intention, and loyalty. We are not trying to club respondents. We are trying to club these variables, so that instead of using 5 variables, can we do the analysis simpler and say come up with 2 or 3 factors. So what we got is that we ran this correlation matrix. This is the first thing that you have to do, and this just gives you that initial understanding, okay, what all variables are coming together, and we realize how many factors can come. How many factors? These 5 variables can be grouped into how many groups or how
Two.
many factors?
Two.
2. Yes. So the first group has What all variables? What all three variables?
Awareness, attitude, and preference.
Yes. And the second one had purchase and loyalty.
Intent.
Yes. So after running this correlation matrix, this is just to give an initial idea. We did this KMO and Barlett test. So KMO is what? KMO is Kazimir-Olkin measure of sampling adequacy. So we want a value which is greater than what value we want for to proceed with factor analysis. This value should be, when do we say that KMO is statistically significant?
Greater than 0.5.
Yes, greater than 0.5. And what is this Barley test? What is the null hypothesis for Barley test? This is greater than 0.5, 0.626 KMO. Okay, KMO is statistically significant. And what is this Barley test? We look at this value, significant value. So what is the null hypothesis?
All variables are uncorrelated.
The variables are uncorrelated, or say identity matrix. Okay, so variables are uncorrelated. We see the significant value is 0.00 less than alpha, that is 0.05. We reject our null hypothesis or alternate.
Null
Null
hypothesis.
Yes, we reject our null hypothesis and we accept the alternate that these variables are correlated. Okay, our assumption, the first assumption that variables should be correlated is met. Let's proceed with factor analysis. So there are two methods of doing factor analysis. This is something called PCA, principal component analysis, and CFA. Okay, let's see this. One is exploratory factor analysis, under which comes our PCA, principal component analysis, and common factor analysis. And one is confirmatory factor analysis. Remember, I showed you that Telecom brand example. Something a priori was written there. Remember?
No, ma'am.
No, just let me go back there. Okay. Yes, this one. A priori factors. So in this study, the client already knew that what all factors are going to come. So she already had this idea that, okay, these variables are going to get together and they're going to be, say, 18 to 20. She already had this idea. So she was only trying, we ran this factor analysis just to confirm, okay, what researcher already knew. So that is called a priori. When you already know that, how the outcome is going to come. That is a priori factor analysis. You are just confirming. Okay, this is confirmatory factor analysis. Whereas in exploratory, you don't know how these variables are going to group. Okay, that is exploratory. That is the difference. Okay, are you able to understand this? Confirmatory and exploratory. What is the difference? Confirmatory, when you already know, okay, how the variables are, what all how many factors you will get. Basically, how many factors you will get. Okay, you already have this idea. You put those many factors and then run the analysis. But we are not going to do CFA here. Just remember that what is the difference between CFA, that is confirmatory, and what is the difference between exploratory and confirmatory. That's it. Now, then there is something called principal component analysis, PCA, and common factor analysis. So PCA is very important and very widely used. And even machine learning algorithms also, we use principal component analysis. Okay. So here what we are trying to do is we are considering this total variance and then we are deriving factor. Whereas in common factor analysis, you are using only the common or shared variance. Okay. So what is the difference? Here you are using total variance and here you are using shared variance. This common factor analysis is quite difficult and that's why is less used. It's quite complicated and so it's less used. Okay, so we use generally this principal component analysis, which is very widely used. For this analysis also we'll use this principal component analysis. This is only that you have to remember. You don't have to remember anything else. Okay, exploratory and confirmatory. I have already discussed this. And let's do it through PCA, that is principal component analysis. So let's look at some of the statistics. There's something called Barlett test of sphericity, which we have already discussed, that it checks the hypothesis that the variables are uncorrelated. There is correlation matrix. We have checked this also. Next is commonality, that is the variance which is explained by a common factor. So in insomnia, what is the variance explained? That is commonality. We have checked this. After that, there's something called eigenvalue. This is the variance explained by each factor. I'll show you the SPSS output. We'll be able to understand something called factor loadings. It's the simple correlation. Factor loading plot is just plot of these factor loadings. Then something called factor matrix is just matrix of factor loadings. Factor scores, this is of each respondent. Here all these are summated, okay? But these are for each respondents. And for running subsequent analysis, say you have to run regression analysis after doing factor analysis. So what you use is you use the respondent scores. You use factor scores. Okay, after that KMO we have discussed. Okay, residuals, scree plot, this is all we are going to discuss now. So remember this, I showed you this common factors, and I showed you, okay, for insomnia, what you have to remember is there's something called shared factors. Say for insomnia, it's depression and anxiety, which is common or shared factor, and something called unique factor, that is E1, which is unique to insomnia. So what is commonality? The amount of variance that is explained by these common factors. This is commonality. So what you get in commonality is something like this. This is 1, this is initial, this is 1, and this is some extraction figures that you see. So this is commonality. So this extraction value tells us the proportion of variance for each variable that can be explained by the common factors. So in awareness of Nike, this much 85% can be explained through these common factors. Next is how many factors. The most important thing is, okay, we have to group these variables into factors, but how do we decide how many factors we take? So there's number of ways of doing that, but graphical method, that is scree plot and eigenvalues, is very, very important method. So let's see what are the various methods. First is a priori determination. So in this case, we are not doing a priori, we are using what principal component analysis. But if you have a priori, you already know how many number of factors will come. Okay, so we are not using this here. Determination based on eigenvalues. So if your eigenvalue is greater than 1, only those factors are retained. Determination based on a scree plot. This is a scree plot of these eigenvalues only. And wherever you see that bend, okay, we'll discuss this. You retain only those factors. Then there is something called percentage of variance. How much variance these factors are able to explain. So we go by, 60% is decent variance. If they are explaining 60% of the variance, then those many factors are good to go. Remember, we have to do data summarization. So it's best that we go with a solution wherein we have, less number of factors which are explaining maximum of the variance. So next comes the number of factors. Okay, this is a very, very important table. So what is this? This is your eigenvalues. Eigenvalues is percentage of variance that is explained by each factor. What is this? This is factor. Remember, we have 5 variables: attitude, awareness, preference, loyalty, purchase intention. Okay. If you have 5 variables, you are going to have 5 factors only. But what we do is that we try to figure out what are the factors which are explaining maximum of the variance. So अगर मेरे पास 5 variables हैं और 5 factors हैं, तो कितना % variance वो explain कर देगा? It will explain 100%, isn't it? If I have 5 variables, I'm using whole data, then it will explain 100%. But we have to see that how many factors can we, reduce it to, so that I can explain at least 60% of the variance. So first thing is that look at these eigenvalues. Just add these. क्या सम आता है? 2.386 plus 1.746 plus 0.435 plus 0.241 plus 0.192. What is the value? Add these. ये जो हमारे फर्स्ट कॉलम में है. Yes.
5.
5. So whatever the number of variables you have, or, those many, that value you will get once you add all these eigenvalues, this number. Okay, ये सारी values add करने पे you will get the value which is equal to your total number of variables. Okay. Second is this explain the percentage of variance. So this first factor is explaining 47.716 percentage of variance. This is explaining 34% of percentage of variance, and go on. Okay. What is this cumulative percentage? So 47.716 is the same, that cost gets transferred. Add 47 and 34.
82.639.
80.
2.639.
Yes, that is cumulative, 82.639. So 47 plus 34 gives 82. Then 82 plus 8 gives 82.69 plus 8.703.
91.342.
Yes. Similarly, this plus this gives this. This plus this gives this 100%. Okay. So now I showed you the slide wherein we discussed that eigenvalue जिसकी भी ज़्यादा है greater than 1. Okay, it should be greater than 1. So eigenvalue, only factors with eigenvalue greater than 1 are retained. So see here, the eigenvalue is greater than 1 for how many factors? This is eigenvalue. It is greater than 1 for how many factors?
2 factors.
So
For 2 factors. So only we are going to retain only 2 factors. Okay. The first factor is explaining what percentage of variance. First factor is explaining 47.716 of the variance. Okay. And these 2 factors combined variance is, what is the variance that these 2 factors are explaining?
82.639.
82.639. And we said that, okay, if it is higher than 60%, it's good to go, isn't it? So it's explaining, these 2 factors are explaining 82% of the variance. So what, we are not going with 5 variables. We can summarize the data by using only these 2 factors, because these 2 factors can explain 82% of the variance. Okay, do one more thing. We can also calculate this variance from this eigenvalue. Okay, the sum is 5. Okay, the sum for this is 5. 2.386 divided by 5. Divide this by 5. That is the sum. This is the sum na. Iska sara sum. This is 5. Divide 2.386 by 5. What is the value?
0.4772.
Yes. So you get this. You'll get this value. Okay. So you can calculate the percentage of variance from by this also. Okay. So you can get this question also, that what is the percentage of variance, and you have to say Nothing is given here. There's a blank, and you can be asked that, okay, these are the eigenvalues. Uh, what are the number of factors? So eigenvalue is greater than 1 for how many factors?
For two factors, ma'am, why we are we considering greater than one, eigenvalue greater than one?
Okay, eigenvalue greater than 1 is that if it is 1, then it's explaining only itself. If it is greater than 1, and that means it's explaining more variation. That's why we take eigenvalue greater than 1. तो अगर सिर्फ अगर 1 ही है, दैट मीन्स कि अगर 5 फैक्टर्स हैं तो 5 ही फिर वेरिएबल्स वो एक्सप्लेन कर रहे हैं, तो हमारा डेटा समराइजेशन नहीं हो रहा है. ओके, सो दैट्स व्हाई वी कंसीडर आइगन वैल्यू ग्रेटर देन 1. सो ऑलवेज रिमेंबर कि आइगन वैल्यू ग्रेटर देन 1 है तभी हम वो कंसिडर करेंगे. ओके, सो आई वाज सेइंग दैट अगर if you get this table and you have this blank, then you can also calculate this percentage of variance from this eigenvalue. 2.386 divided by 5 and you will get 47.716. Okay, next is, okay, this is what we have discussed. Ki eigenvalue is greater than 1. That is a percentage of variance explained by each factor. If the percentage of variance explained by each factor is 1, that means there is no data summarization. ज़्यादा percentage variance अगर explain करेगा, then only we can club. See, यहाँ पर हमारे पास 100% variance है. Okay, and we are explaining 82% by using, instead of 5, we are using 2 factors. इन 2 factors से हम ये 5 variables को explain कर सकते हैं. Okay. Now, we have done this only factors with eigenvalue greater than 1. And next is, you have checked eigenvalues, you have checked cumulative percentage. Next is called scree plot. So this is a graphical method of seeing how many factors to retain. Okay. So what is this? This is nothing but this is the plot of your eigenvalues. See, this is 2.386. This is 1.746. These values are given here, or see इसमें ही, in this table, 2.386, 1.746. Are you able to see this? 2.386 and 1.746.
Yes.
तो इन values का ही जो ये scree plot बन जाता है, and then how to read this? So it's just like throwing stones from a mountain. Okay, you are throwing stones from a mountain and you see a bend. Okay, यहाँ पर तो slope, it's good slope here, but यहाँ पे जहाँ पर ये slope आपका बिल्कुल कम हो जाता है, you get this flat line kind of thing. उससे पहले जो भी factors होंगे जहाँ पर bend होगा, that many factors you are going to count. Okay, so there's a big drop from this to this. So there is a big drop from this to this, and then there's a drop from this to this, but after that it's going flat. Okay, there's not much of a difference here. Okay, so you will see, take only 2 factors. So हमारे variance, this इसमें भी हमारे कितने factors आए थे? 2 factors, right? This output is also telling us key 2 factors, and our scree plot is also giving us 2 factors, that we should go with 2 factors. So we go with 2 factors. Next is rotating the factors. So we have to do rotation. Basically what we do is, this is 90 degree and we are just rotating this axis. We are rotating this axis. Okay, ये axis थी हमारी initially, we are rotating this axis. What is this rotation? Why we are rotating this? What does that mean? Let's see that. In rotating the factors, we would like each factor to have non-zero or significant loadings or coefficient for only some of the variables. We try to increase interpretability. हम क्या करते हैं? हम एक in SPSS, you have to just tick one option of rotating the factors. Let me show you one example. See this component matrix, okay? This is a component matrix and this is rotated component matrix. Let's see one first this. Okay, these are factor loading, basically the correlation. Okay, this is first factor, this is second factor. Okay, so awareness of Nike will come in which factor? Awareness of Nike will come in which factor? First or second? So it will go in the
First.
yeah.
First.
Yes, first, because the loading is high in first factor. Attitude will go in which factor?
First.
First.
Okay, 0.873 and minus 0.272. And preference?
First.
Okay, what about purchase intention?
Second.
Second.
And this loyalty?
Second.
Second.
Second. Okay. Now check this rotated component matrix. Can you see any difference? यहाँ पर, okay, first, this awareness of Nike will come in rotated component.
First.
First.
But okay, this is also this, also this. But can you see any difference? ये component matrix में और ये rotated component matrix में क्या difference है?
Value increase हो रही है.
Value increase हो रही है, and which one is easier to interpret? If you have to, make a judgment whether the variable is coming in first factor or second, which one is more interpretable?
Both are
Second.
easy, ma'am.
हाँ वैसे दोनों easy है अभी तो.
दोनों ही easy है actually. दोनों easy इसलिए because you have only very less variables. You have only 5 variables. But the gap is more in which one? In
First component matrix, because their first three are negative in component 2. So by seeing negative, we can go there.
No, not just by negative, but see the difference. 0.859, 919, 914, 873 है यहाँ पर. It's more.
In rotated component matrix.
Yeah, see here, okay. If you are getting confused by negative numbers, see here, 0.301 and 0.889, 0.028 and 0.938. Okay, so in rotated one, it's more interpretable. See, here we have only 5 variables. Like I showed you in telecom case, that if we have 100 of statements, and when you do component matrix, you will see numbers like 859 and say 83, and they are so close, that you are not able to understand कि ये factor 1 में जा रहा है या factor 2 में जा रहा है. In that case, this rotation really helps. Okay, it makes the things more interpretable. Now what you have to understand is the rotation. What does this rotation does? क्या इससे variation explain change हो जाती है मेरी? This is your initial one, okay, and this is rotation sum of squared loadings. What is the percentage of variance in this by these two factors? How much percentage of variance these two factors are explaining in this?
82.639.
Yes, and in rotated,
Same.
same. So your percentage of variance that is explained, total percentage of variance that is explained is same. It remains the same after rotation. Only this difference, this changes. The variance explained by each factor changes, but the total variance that is explained remains the same. So what you are trying to do here is you are just shifting the axis. ये एक data point था, ये data point यहीं पर ही रहेगा. But to make it more interpretable, what you are doing is आपकी axis ऐसे थी 90 degree, you are shifting it by 90 degree if it is orthogonal or varimax, and then or oblique. So you are just shifting your axis. तो आपकी जो variation है, whatever variation these factors are explaining, total variation remains the same. There's only shift in variance of individual factors. Okay, that's an important point to remember here. Okay, we have done this rotation. Now is interpreting or naming the factors. So awareness, attitude, and preference, we have already seen there's going to be two factors, and awareness, attitude, preference are coming in one, and purchase intention and loyalty is coming in one as per our component matrix. Okay, we check this rotated component matrix. How should we name them? Awareness, attitude, and preference. Okay, so awareness, attitude, and preference. One way is that we rename it after the variable which has very high factor loading. So इस group में in awareness, attitude, and preference, which one has highest factor loading? Let's see in rotated component matrix.
Awareness.
Awareness.
Awareness. Either we rename it as awareness, okay, or we, but you know, this is like very close, 0.91, 0.9414, बहुत close hai. So either we rename it by using awareness, or we rename it using a common name which goes for all these three. Okay. Similarly, here also the difference is not that much. But when you will do the assignment that I have given you, you'll be able to see the difference. Okay. So what I did is I renamed it as perception, awareness, attitude, and preference. I gave the name as perception. And purchase intention and loyalty, I gave them this name as usage. You can give purchase also.
Excuse me, ma'am.
Yes.
Ma'am, you gave us the road trip assignment and two questions or two, three questions of that case. So do
Hmm.
we have to do this Nike case also?
No, no, no. You don't have to do this Nike case for this factor answers.
Yes.
No, no, no. You don't have to do this Nike case. I'll give you two separate cases. One is inverter case study, and one is Ellen Jeans. Okay.
Okay.
So you do this, and after that, you can interpret factors. This is something that you just take a a graphical method. So purchase and loyalty are going together, and preference, attitude, and awareness are going together. Next is you can calculate factor scores. If you are doing any subsequent analysis, say regression and all, so you can do factor, you can calculate the factor scores. Remember, factor scores is computed for each respondent. Okay, so unlike, have you done that regression assignment that I gave you? Wendy's वाला उसमें आउटपुट रन
Oh,
की.
yeah, almost done, ma'am.
ग्रेट. सो जब तुम आउटपुट रन करते हो तो एक अलग से एक विंडो ओपन होती है
Yes, ma'am.
ना. तो व्हेन यू कैलकुलेट फैक्टर स्कोर्स, जहां पर तुम्हारा डेटा है उस ही विंडो में एक अलग से कॉलम आ जाएगा फैक्टर स्कोर्स का फॉर ईच रेस्पोंडेंट. Okay, and then you can run your analysis on this factor scores if you are going for subsequent analysis like multiple regression or any discriminant analysis. So this is factor score, but it is calculated for each respondent. Remember this. After this, computing this factor scores, you can also select surrogate variables. For example, in this component matrix, like I showed you, attitude awareness की सबसे ज़्यादा loading थी, or I think it was for attitude. If the difference is very high, okay, for a factor, let me show you this. यहाँ पर बहुत ही क्लोज था. दिस इज 919 914 804 से यहाँ पर 021 है या 031 है, यहाँ पर 919 है. सो अवेयरनेस से आई कैन एक्सप्लेन दिस factor. I need not to take these variables. I can remove these variables and say awareness of Nike I can take as a surrogate for my perception. Okay, and I can drop these variables. So that is the funda of what you call surrogate variables. Okay, if the factor which has highest factor loading, we can use this. If there is very much there is stark difference between these factors, I need not to take all other variables. I can just take only one. Okay, Next is that you determine the model fit. It is nothing but, you are checking what is the residual. How do you check the fit, whether the model is fit or not? You check what is observed, what is estimated, and check the residuals. So what you have to do is just, in this table, in this table, can you tell me all those which has value, how many values are greater than 0.05 in this unique values? How many are greater than 0.05?
4 values.
Okay, no, this, I'll just quickly do this, and this. Unique values. So residuals are computed between observed and reproduced correlation, that is observed and estimated using this factor analysis. And there are three non-redundant residuals. So यहाँ पर 0.112 यहाँ पर भी है, 0.112 यहाँ पर भी है, because you are doing loyalty and purchase, okay, and then purchase and loyalty पे भी ये एक बार और आएगा. But I am talking about non-redundant residuals. So it's only 3. So that's 30% is the value. So that is good. Your residual value is very less here. Now,
You said greater than 0.05.
Yes, ma'am.
These are minus values.
greater than 0.05.
You have circled minus values.
Yes, ma'am.
Yeah, you can take that minus value. Yeah. Okay. So next is,
Ma'am, didn't get you.
okay. So what is this? Or you just see this. This is something that, SPSS will do itself. Residuals are computed between observed and reproduced correlation. There are three, that is 30% non-redundant residuals with absolute values greater than 0.05. So you are looking at absolute values. You are ignoring negatives here. Okay.
Okay, got it.
So the first assignment that you have to do is on consumer perception on inverters in India. So I'll share this case. What you have to do is you have to punch the data and run analysis, factor analysis here. And then second one is marketing dilemma for LNG's brand. Okay, you have to submit this and we'll discuss this in next class. And there are some questions given at the end of this case as well as this first one also. For LNGs, I'll share the, I have already punched the data. I'll share you the SPSS file. But for this this inverter case, just punch the data and run it. Okay. Now I'm also sharing this SPSS screen captures. How to do this? Analyze, go to analyze. Regression के लिए कहाँ पर जाते थे हम? After analyze, we go to
Regression.
yeah,
Regression, then linear.
Regression.
great. Okay, assignment किया है. Okay.
And then linear regression. That was in second one.
Yeah, in this यहाँ पे linear regression आता था. Yes. So here you have to go analyze dimension reduction because we are reducing the dimension, okay? And then you select factor analysis. I'm just going through this part so that you remember कि ये सारे outputs हमने already देखे हुए हैं. You'll be able to remember this path as well because we have already covered what all outputs are going to come. So हम analyze में जाते हैं. So we go to dimension reduction because we have to reduce dimension. हम select करेंगे factor. After that, सारे वेरिएबल्स इधर चले जाएंगे. रिमेंबर रिग्रेशन में हमारे पास कुछ इंडिपेंडेंट और डिपेंडेंट करके एक विंडो आता था. तो डिपेंडेंट में एक जाता था एंड ऑल अदर्स इफ वी आर रनिंग मल्टीपल रिग्रेशन. सो और सारे वेरिएबल्स इंडिपेंडेंट वेरिएबल्स के विंडो पे जाते थे. बट हियर वी आर रनिंग फैक्टर एनालिसिस एंड द क्वेश्चन सेज दैट यू हैव टू रन ऑल द वेरिएबल्स. सो व्हाटएवर वेरिएबल्स यू हैव जिस पे तुम्हें फैक्टर एनालिसिस रन करना है, you put all these variables here. Okay. So here this is respondent. We are not using respondent. We are not putting respondent here. We have to run, for example, here on these 6 variables. So all these 6 variables will go here. All right. After that, you have to mark initial solution. Remember commonality component matrix, मैंने एक वो show की थी जहाँ पर initial solution 1 1 1 extraction value थी और कुछ values second column में थी. So check initial solution. Reproduced because we are checking residuals. KMO and Barlett test, very important. हमने KMO and Barlett test किया था after correlation. And then descriptors. What you get after that is this method. What method we are using here? Principal or CFA? What method are we using here?
Principal.
Principal component analysis. So select principal component here. We want correlation matrix. Why? This is the first step. Okay, we want to check what is the correlation. Then unrotated factor solution also. We need unrotated factor solution. Remember that variance table, we had this unrotated and then the rotated ones. Okay. Eigenvalue, what we want to retain only those factors which has eigenvalue greater than 1. So put 1 here and then continue. Okay, you extract. Next, you go with varimax. I think varimax is one which has 90 degree. Okay, so this is the method, varimax method. You go display rotated solution because you have to rotate and you have to check what, you are not changing the variance by rotating. You are just increasing the interpretability. So you select rotation. And if you want factor score, then you select this also underscores. And that's it. And then you will get all the outputs. Okay, easy. Yes.
Ma'am, if we, as you said, you have to say, submit one document and one PPT. So if we add the Wendy's case in the PPT, it will be too large.
Why? Okay, it's going to be too large. Okay, whatever way you want to submit is up to you. It's your call.
Only this assignment will be evaluated and not previous assignments. So can we submit only this assignment in the presentation?
Which assignment?
Like previously you gave more assignments for the case. So do we need to attach them also, or we just need to attach the latest one?
So okay, your 10%, that is your say C3 or C4, whatever it is. So your 10% component, I'm dividing it into these 4 topics. Okay. For regression, I have already given you a road trip one and your case. Okay. For this, for factor analysis, you have to do 2 cases.
No, ma'am, I'm asking about regression only. That we need to only give the assignment for regression only, no? You
Ah,
gave previous assignments for those cases. Do we need to attach them also? Or
no. What previous? I'm not able to get what previous
मैम
assignments.
पहले आपने दिया था ना वो नॉमिनल स्केल और उससे भी पहले की रिसर्च प्रॉब्लम क्या है वो नहीं करना ना
नहीं. No. You have to
सिर्फ
do,
ये वाला ही देना है
yeah, those questions are on regression. Okay.
Ma'am, there was also one problem. Ma'am, I text you for attendance. Attendance issue, ma'am.
Yeah, Rahul, I'll talk to you regarding that. Yeah.
And ma'am, what about the live project you were supposed to give us in today's class?
No, not in today's class. Yeah, I said next session. That means, next class.
Okay.
Our next class is on 23rd. Or maybe I'll share one document with you. Okay. So you can do all, communication regarding that on that group. Okay. Or if you have to go, individually you want to talk about it, we can do that. And I would prefer a group call. So first, how to proceed on this? In next session, I'll talk about it, about the live project, how to select the topic, what all topics you can do, all those things. Okay. How you are going to be evaluated. You have to submit report in what format. You have to do data collection, all those things, how to check quotas or everything, everything I'm going to discuss in next session, or maybe share one approach note with you. What I want is that we should be able to close this questionnaire in this year only. And after that, you have to do analysis and all. So in next session, we'll discuss this about this live project. And then after that, maybe every Friday or Saturday, we can discuss in groups. Okay, what is the progress? All right.
Okay, ma'am. Okay.
Okay, bye-bye.